Hi there, it's Mrs. Ortiz here, and I am going to go through the examples for the midpoint on the derivation or the explanation of what the midpoint formula is. So this is page 11 of your notes, and I'm going to do number 8, and I'm going to do number 9, and then I'm going to do example 12 and example 13. Okay, so if you're looking for information on the distance formula, you would want to find the distance formula video. Okay, so for number 8, we're going to take a look at number 8. It says find the midpoint of AB if A is at -2, 6, and B is at 3, -6. So the first thing we're going to do is go ahead and plot those. So A is at -2, 6. Right here. And B is at 3, -6. So we're going to go over 1, 2, 3, down 6. Right here. And then we can go ahead and connect AB into a segment. Okay. And then we know that we are looking for the midpoint, and we've defined the midpoint. The midpoint is the point that divides a segment into two congruent parts. So midpoint, point in the middle, right? Mid being middle. And so we are looking for the coordinates of the midpoint, all right? So think middle. You want to find the point, the coordinates of the point that are halfway between A and B. And so when you're thinking halfway between, coordinates work with X and Y. So think halfway between X and halfway between Y. So when we look at -2 and 3, and we think about halfway between them, we can essentially take the average, right? Or if you think about it on a number line. And so halfway between -2 and 3 is 1/2. And then similarly, halfway between 6 and -6 will just be 0. So this midpoint, if we call it M, has the coordinates of 1/2, 0. Now, if you think about what we did algebraically, we took -2 plus 3, and then we divided that in half, right? So that's halfway in between. That's an average. And then for our y coordinates, we took 6 plus -6 and divided that by 2. And there were your coordinates for the midpoint. So let's apply this when the coordinates are variables. So I'm going to switch colors here. And we're going to look at number 9. So now suppose that A is at the coordinate x(1), y(1), and B is at the coordinate x(2), y(2). Find the midpoint of AB. Well, it's the exact same process. You want to find the middle of your x coordinate and the middle of your y coordinate. Okay, so to find the middle, we can average it. So the midpoint M is going to be at the average of the x coordinates, which is x(1) plus x(2) divided by 2, comma, for the y coordinate, we're going to do y(1) plus y(2) divided by 2. And that's it. That's the formula for the midpoint. Okay, so to find the middle, take the average of the x coordinates and the average of the y coordinates. So the coordinate of a midpoint in the coordinate plane, x(1) plus x(2) divided by 2, comma, y(1) plus y(2) divided by 2. Okay. All right, so let's take a look at a couple examples for midpoint. In number 12, it says find the coordinates of the midpoint if the endpoints are at 2, 3, and 4, -3. So those are your two endpoints. So the midpoint is going to be the average of your x coordinates, 2 plus 4 divided by 2, or halfway between 2 and 4, and 3 plus -3 divided by 2, or again, halfway between 3 and -3. So 2 plus 4 is 6, 6 divided by 2 is 3, and 3 plus -3 is 0, 0 divided by 2 is 0. So the coordinates of the midpoint are 3, 0. When we look at number 13, it says given the endpoint 2, 6, and the midpoint, negative 1, 8. Find the other midpoint. So you can use the formula, and you can say, if you're just looking for the x-coordinate, if you know the x-coordinate of the midpoint, so I'll call it x sub m, we know that that's x sub 1 plus x sub 2 divided by 2. Okay, so we know one endpoint is 2, so we can substitute that in for x sub 1. And then we don't know the other endpoint, that's what we're trying to find, divided by 2. But we know the midpoint, the x-coordinate of the midpoint is negative 1, then we can solve for x sub 2. All right, so we're going to solve for the other endpoint. So we multiply both sides by 2. We get negative 2 is equal to 2 plus x sub 2. When you subtract 2 from both sides, you get x sub 2 is equal to negative 4. And then you can do that same process for the midpoint, the y-coordinate. So if we switch colors, okay, we know that the y-coordinate of the midpoint is the average of the y-coordinates on the endpoints. Okay, and we can substitute everything in. So we know the y-coordinate is 8 is equal to 6 plus y sub 2 divided by 2. Multiply both sides by 2, we get 16. And that's equal to 6 plus y sub 2. Sorry, I'm kind of everywhere. Oh, y sub 2. All right, and we're going to subtract 6, and we get y sub 2 is equal to 10. So you can definitely use the formula if you would like. However, if you've hung out with me through all of that, then you probably deserve to know my preferred method, and that is to kind of think about it as a picture. So let's look at this again. Ooh, get rid of all of this. And let's draw a picture of what is actually happening here. So, more of that junk from the formula. Who needs formulas anyway? Just kidding. That was a really bad joke. So, okay, so we know that we have a segment with a midpoint. Okay, so our segments are congruent. There's our midpoint. One endpoint is 2, 6. The midpoint is negative 1, 8. And I didn't put this on a coordinate plane, but you definitely could. And then we're trying to find the coordinates of the other midpoint, or the other, oh, that's supposed to say endpoint. Oh my. Okay, so for the other endpoint, if you went from 2 to negative 1 to get halfway, then you subtracted 3 for your x-coordinates. So then from negative 1, you're going to subtract 3 again, and you're going to end up at negative 4. For your y-coordinates, if you went from 6 to 8, you went up by 2 to get halfway. So to go the other half, add another 2 to the middle, and your coordinate will be negative 4, 10 for the endpoint. All right, that's all I have for midpoint. Have a great day. Bye.